So this is the second question that we have taken on the calculation or evaluation of equivalent resistance of a circuit. So here also we have to well, there is nothing much to separate and divide the circuit into, but here in these type of circuits uh, what you can do is that you can approach it from one side to the other. Okay, so what we can do is that we will solve this circuit by going from this right end towards left, okay, towards the point x, y. So we'll move in this direction. So first look at the 2 ohm resistor and this 2 ohm resistor. Okay, it looks like it's connected in this way, okay, like a triangle shape, but actually they are connected in parallel, okay, in this way. This 2 ohm and 2 ohm, they are connected in parallel. The left ends of these two resistors are connected at this point and the right ends are connected at this point. Okay, so if we connect a voltage source just like I showed you previously, then the voltage across each of the two resistances will be the same and current division will take place at this point. It means that these two resistors are in parallel, okay, they are connected in parallel. Now, so directly let us calculate the equivalent resistance, which is equal to R equivalent is equal to 2 into 2 by 2 plus 2, which is equal to 4 by 4, which is equal to 1 ohm. So the equivalent resistance is 1 ohm. So if we redraw the circuit will look something like this. Okay, this is sorry, there is another resistor here, 1 ohm, this is 1 ohm, this is 2 ohm, this is 5 ohm, x and y. Now these two 1 ohm and 1 ohm resistors are in series, okay, they are in series. So what we can do is that we can again combine them and again redraw the circuit. Okay, this 1 ohm resistor is the equivalent resistance of these two 2 ohm resistors connected in parallel, this 1 ohm. So again if we combine them, okay, if we combine them, so we simply add the two resistance values 1 ohm and 1 ohm, so we will get 2 ohm resistor like this. Okay, now these two 2 ohm resistors are in parallel connection. Just by looking at it we can say that. Why? Because you can see these top ends of the 2 ohm resistors, I am using the word the terms top and left and right just to make you understand. It means that the two ends of the resistors are connected at one common point and the other two ends are connected at another common point. Okay, it means if we connect a voltage source across this, the voltage across each of the 2 ohm resistors will be the same. Okay, so these 2 ohm resistors, okay, the two 2 ohm resistors are in parallel with each other with respect to each other. So the parallel equivalent resistance will be the same expression, the 2 ohm and 2 ohm resistors, so it will be 2 into 2 by 2 plus 2, which is 1 ohm. So the equivalent circuit will be, just remove this and this will become 1 ohm. Okay, now this 1 ohm resistor is in series with the 5 ohm resistor, this 5 ohm resistor. So just look how we have reduced the circuit by moving from left to right. Okay, just by proceeding from left to right, moving gradually towards these 2 points, we went on reducing the circuit, calculating the equivalent resistance of a pair of resistors. First we took 2 ohm and 2 ohm, then we added the equivalent resistance of these two resistors with 1 ohm. Again we calculated the equivalent resistance of the uh, calculated resistance with 2 ohm, and then we calculated this value as 1 ohm. Now as these two resistors are in series, then the equivalent resistance will be simply 5 ohm plus 1 ohm, which is 6 ohm. Okay, so the equivalent resistance will be 1 plus 5 be 6 ohm. So the total equivalent resistance is 6 ohm. So in these type of circuits, the approach should be that you start from one end, preferably the end opposite to the end across which you have to calculate the equivalent resistance. Don't move from this side to this side, it can create confusion. Always move from the opposite end towards the two end across which you have to determine the equivalent resistance. Okay, that will make it easy for you. Okay, so here we moved from right end to left end, and we went on calculating the equivalent resistance of the resistors which we encountered in the path. So finally we calculated the equivalent resistance as 6 ohm. Okay.